Gravity is a fundamental force. It shapes the universe we see, from the smallest particles to the grandest galaxies. It holds our feet to the Earth and keeps the Earth orbiting the Sun. Many think there is no gravity in space. This is a common misunderstanding. Astronauts on the International Space Station appear to float. They look weightless, free from Earth's grip. But gravity is very much there. The ISS is only about 400 kilometers up. At that height, Earth's gravity is still strong, about 90% as strong as on the surface. The astronauts in the ISS are in a state of free fall. Imagine throwing a ball horizontally. It travels forward, but gravity pulls it down. Now, imagine throwing it incredibly fast, so fast that as it falls, the Earth curves away beneath it. It keeps falling, but it never hits the ground. This is what an orbit is, a constant falling around a planet, a delicate balance of speed and gravity. The feeling of weightlessness is not the absence of gravity. It is the experience of falling at the same rate as your surroundings. The ISS provides a continuous version of that moment. Let us delve deeper into gravity. Sir Isaac Newton gave us a foundational understanding. Every object with mass attracts every other object. The Sun, with its enormous mass, holds planets in orbit. Albert Einstein expanded on this. Gravity is a curvature in the fabric of space-time. Light itself bends as it passes massive objects. Gravity is the cosmic glue. The International Space Station is a marvel. It orbits the Earth at incredible speed, roughly 28,000 kilometers per hour. This immense speed is crucial. It is what keeps the ISS in orbit, balancing Earth's gravitational pull perfectly. It is constantly falling towards Earth, but it is also constantly moving sideways fast enough to miss. This state of continuous freefall creates microgravity. Inside the ISS, everything floats. Astronauts, tools, droplets of water. It is not true zero gravity. As we have discussed, Earth's gravity is still strong, but everything inside the station is falling together at the same rate. This creates the sensation of weightlessness, a unique environment for science and discovery. Living in microgravity is an extraordinary experience. It changes how astronauts perceive up and down. Every surface can be a floor or a ceiling. Simple tasks require new techniques: eating, sleeping, even moving around. Astronauts must anchor themselves to work, otherwise a slight push sends them drifting. The ISS itself needs regular adjustments. Even at its altitude, there is a tiny amount of atmospheric drag. This drag slowly reduces its speed, causing it to lose altitude over time. So spacecraft periodically dock and fire their thrusters, ensuring its mission can continue safely. Now, let us imagine the truly impossible. What if, suddenly, gravity around the ISS just stopped? Not the microgravity effect, but actual gravity, the fundamental force that holds it in orbit. Imagine Earth's gravitational pull on the ISS suddenly vanishing, or perhaps the very fabric of space-time around it becoming flat. This is not something science predicts. Physical laws are thought to be constant. But for this thought experiment, let us explore it. The ISS is traveling at 28,000 kilometers per hour. This immense velocity is what keeps it falling around Earth. If Earth's gravity holding it in that curved path disappeared, the ISS would no longer be in orbit. Newton's first law of motion would take over. An object in motion stays in motion in a straight line, unless acted upon by a force. Without gravity, the ISS would fly off. It would depart Earth's vicinity tangentially, like a stone released from a sling, flung into space. The direction would be a straight line, tangent to its previous orbital path. It would continue at that enormous speed, drifting further and further into the solar system. A tiny man-made object lost in the cosmic ocean. This is, of course, purely hypothetical. Gravity is woven into the fabric of existence. Inside the ISS, the moment gravity vanished would be bewildering. The astronauts are accustomed to microgravity, the sensation of constant freefall. But this would be different. If only Earth's gravity affecting the ISS disappeared, the astronauts inside would still have their own tiny gravity, and the station's mass would exert a tiny pull. But relative to Earth, they would be unanchored. Their world, already strange, would become utterly alien. The immediate physical sensations are hard to predict precisely, because such a scenario defies known physics. However, if the station were suddenly on a straight path, no longer curving with Earth, there might be a brief, strange sensation. As the constant falling sensation, the microgravity, abruptly changes. Perhaps a lurch or a feeling of being pushed, depending on how this gravity loss manifested. The delicate inner ear balance system might be confused, leading to disorientation or nausea beyond the usual space adaptation. Panic would undoubtedly set in quickly. Alarms would blare. Communications with Earth would be frantic. The crew would know something catastrophic had occurred. Their training prepares them for many emergencies, fires, depressurization, system failures. But the loss of the fundamental force keeping them near Earth, that is beyond any conceivable contingency plan. Fear for their lives would be immediate. The International Space Station itself would face immediate peril. Its structure is designed for the stresses of launch and the environment of microgravity. It is not designed to suddenly be flung or to experience a complete absence of external gravitational force. If the loss of gravity was a sudden jarring event, it could impart stresses on the station's modules, the delicate connections, the solar arrays. There could be structural damage, a breach, a loss of integrity is possible. Inside, the carefully managed environment would be disrupted. Equipment is secured, but not for such a jolt. Experiments could be ruined, sensitive instruments damaged, loose items would become projectiles, if there was a lurch. The life support systems rely on predictable conditions. Power generation from solar arrays might be affected if the station started tumbling due to an uneven force or if its orientation could no longer be controlled. Pointing towards the sun becomes critical. Without power, the station dies. Navigation and control systems would be useless. They are designed to work gravity, to maintain orbit, to adjust attitude. If the fundamental input, Earth's gravity, is gone, the computers would be struggling with impossible data. While losing gravity is purely fictional, space history has seen its share of real crises. These events teach us about resilience, about ingenuity under extreme pressure. Consider the Apollo 13 mission in 1970. An oxygen tank exploded en route to the moon. Houston, we've had a problem. Their command module was crippled, their lives hung by a thread, but they did not give up. Astronauts and ground control worked together, against incredible odds. They used the lunar module as a lifeboat. Engineers on Earth devised ingenious solutions, using only materials available on board to filter carbon dioxide, to navigate. It was a triumph of human collaboration and a testament to calm thinking in crisis. They returned safely to Earth. A near tragedy turned into a historic success. The Russian space station, Mir, also faced emergencies. In 1997, a fire broke out in an oxygen-generating unit. The crew fought it bravely in cramped, smoky conditions. Donning masks, they battled the flames. Just months later, a Progress cargo ship collided with Mir. It struck the Spectre module, causing a depressurization. The crew had to seal off the module quickly, losing valuable experiments and personal belongings. In our hypothetical scenario of ISS losing gravity, the first response would be utter disbelief on board the station and at mission control. Data streams would show something impossible, the station's trajectory inexplicably changing, telemetry readings going haywire. Engineers would scramble, checking every system. Could it be a sensor malfunction, a catastrophic miscalculation? But the truth would become undeniable. The ISS is no longer bound by Earth's gravity. Once the initial shock subsided, if possible, the focus would shift to astronaut survival. Assuming the station is intact but drifting, communication would be key, as long as it lasts. Astronauts would report their status, their observations of the impossible. Ground control would try to understand the new physics, an impossible task, but they would try. Could any thruster burns alter the new trajectory? Could they steer it towards? This thought experiment, the ISS losing gravity, it highlights something incredibly profound, the stability of the laws of nature. These laws, like gravity, are not arbitrary. They are the framework of our universe, consistent across vast stretches of space and time. We rely on them for everything, from building bridges to sending probes to Mars. The predictability of gravity allows for orbits. It allows for stars to shine steadily. It allows for life to evolve on planets. Our entire scientific understanding is built on this consistency. If a fundamental force could just switch off for a specific object in a specific place, then our universe would be chaotic, unpredictable, perhaps unknowable. The ISS orbits Earth because gravity works, always reliably for everything with mass and energy. This dependability is a form of cosmic reassurance. It allows us to explore, to understand, to exist. It is a gift of the cosmos. So while it's engaging to imagine such scenarios, we can be thankful that gravity is steadfast.